A 1 kilogram object falls from a height of 20 meters. Just before it hits the ground, what is its speed? Well, to solve this question, we can use conservation of energy. That is, the energy before it begins to fall must be equal to the energy after. So in other words, at the very beginning, before the object is let go or begins to fall, it has potential energy. And at the very end, right before it hits the ground, it has kinetic energy. And those must be equal since energy is conserved. So the energies that are before are simply potential energy. There's no kinetic energy because it's not starting with motion. So there's just potential energy. And it's some initial potential energy. Afterwards, there is kinetic energy, EK final. And now we can plug in the equations for potential and kinetic energy and then solve for the velocity. Well, potential energy is mgh and kinetic energy is 1/2 mv final squared. We see that there's a mass on both sides, so that will cancel. And we are trying to solve for velocity. So let's isolate v. If we do that, we will have 2gh initial, all inside a square root sign. Now we can simply plug in our values. 2 times the gravitational constant, which we've been told is 10 meters per second squared. I'm simply going to write 10 without the units. And then the height is 20 meters. Well, 2 times 20 is 40, multiplied by 10 is 400, and the square root of 400 is 20. So 20 meters per second is the velocity right before the object hits the ground.